Hello, everyone. Thanks for being here today. My name is Jeff Mendoza.
Hey, everyone. I'm Ben. Good to have everyone here today.
Yeah, and we're here today to talk about both build time, runtime, SBOM, supply chain information in your clusters using both Kubescape and GUAC. Okay, a little background about myself. I'm a software engineer at Kusari, which is a software supply chain security startup. And I'm a maintainer of GUAC, which is an OpenSSF project licensed Apache 2.0. So I'm also involved in a couple other OpenSSF projects and also the clearly defined project.
So as I said before, I'm Ben, one of the maintainers of Kubescape, which is we'll talk a little bit later about that, but it's a Kubernetes security platform and the CNCF incubating project. And I'm coming mostly from software engineering and the security product side of the industry.
Just a brief overview of the talk. We're going to talk a little bit about the two projects and then some exciting new features that have just launched and a demo. All right, so I'm going to bring you all up to speed on GUAC. GUAC stands for, it's a backronym, you know, we like avocados and, and guacamole, but it stands for Graph for Understanding Artifact, now I forgot what the C was, composition. So what it is a system that you bring up, and it's at the core of it is a GraphQL API. But it pulls in all kinds of supply chain data from all kinds of sources or types of documents. Primarily software bill of materials, SBOM, but also SALSA attestations, scorecard scores, VEX documents, things like that. And it brings it all into a system that you're able to use those GraphQL queries to derive insights about your entire supply chain. So if an SBOM just contains the contents of a single piece of software, you get all of those into one big graph and you start seeing the interconnection between all of your software. The way you typically use it is, at least up until now, is you would have like a step in your build that would generate an SBOM and then ingest or upload that SBOM into the GUAC system that you're running. To dive a little bit more into the different components that make up GUAC, what you see here in green is the core project of GUAC. The database and assembler is what runs the API, but there's a lot of other pieces that sit around it. So for example, the ingester is what takes documents in and then hydrates the graph with all the, turns the documents into nodes and edges that go into the graph. And then we have these things called collectors and certifiers. So a collector would be something that either watches for new data or goes out and like grabs data. So a typical example is the file collector, that's for SBOM files. But other ones are collectors that can sit and look at like your GitHub repo for when you have a new release. Oh, I'm going to check to see if that has an SBOM, download that, and then put that into GUAC. We also have collectors for a number of other integrations like that. And then on the certifier side, it's going to vulnerability sources like osv.dev to say, it looks at the graph and says which packages are there, and then it gets more information from those external sources. So vulnerabilities end up being added as nodes to the graph, as well as like those scorecard scores I was talking about. So here you see on the bottom, going in are the different sources that those collectors are written for. And that gets pushed up into the GUAC system. And then on the top are things that you can use to access all the information in the GraphQL API. So there's, of course, GraphQL itself. If you write queries to, say, I'm interested in which package is connected to this package, is connected to that vulnerability, things like that. We have a CLI to just, answer some typical questions. A visualizer, I'm going to show that a little bit later. And then whatever your ideas are. So I think in Paris there was a talk about GUAC and OPA to do policy for Kubernetes. So there's a plugin for that as well. Yeah, I think that's about it.
Okay, so a few words about my project, my CNCF project, but the project I'm maintaining. So Kubescape started like 4 years ago, the project. It used to be, it started as CLI for scanning Kubernetes and live API and YAML files for misconfigurations from a security perspective. Originally it was really built upon open policy agent and implemented a lot of controls, security controls, frameworks, and so on. And the project really fastly evolved into a full-fledged Kubernetes security platform. So both you can, Kubescape has a version of that can be installed as an operator in your Kubernetes cluster, and it covers quite a lot of things that you would need from a security perspective when managing a cluster, and Kubernetes doesn't give you that out of the box. We started from configuration scanning. We have a vulnerability scanner, which is going to be, I think, the focal point of the discussion today. But beyond that, we have an eBPF node agent that does a few quite nice things like network policy proposal, second profile management, and beyond that, anomaly-based runtime detection. And we are Kubescape in its different versions are available, as I said, as a Kubernetes operator, as a CLI tool, as a GitHub action, as a Visual Code plugin. So the project went up to a great start, and today we have a lot of love that we get back from the community, and a lot of contributions, a lot of usage, which is really, really great as an open source project. So the thing I'm going to focus on today is revolves around vulnerability scanning and package management, SBOM, and here's our connection with GUAC. So is there here anyone who is in his daily work does vulnerability management? Hands up. Yeah. Is it fun, right? Cool thing, not very nice. We love it. So, so one of the things we really like in our project is just to try to come towards the engineers, towards the security person, and try to solve things that you would need to do manually and solve them, through different smart things. And one of the major problems that all of us who are doing vulnerability management are more or less, affected by is that we need to fix vulnerabilities. We need to scan for vulnerabilities. We need to keep an updated log of what kind of packages we have in our environments, where they are running, and what vulnerabilities they have, and we need to do it constantly and monitor this thing. While the main issue with that is that although all of these vulnerabilities, to some extent, there is some kind of a conjuncture where you could exploit them, because otherwise they wouldn't be called vulnerabilities, in most of the cases, they are not real threats to our environments in a Kubernetes cluster because of myriad of reasons, which I'm going to talk about a little bit later. So here comes the reachability feature, reachability analysis in Kubescape. So we love other open source projects as well. So when we went into the eBPF world, we decided to use Inspector Gadget, which is another great CNCF project in Sandbox today. And the thing that we come up with is the following simple idea. Today, when you take a Kubernetes workload, you can look at the YAML file, see where the image is what the image that it is running, take this image, put into a scanner, and get hundreds of vulnerabilities instantly, which is super annoying. Now the problem is that all of these vulnerabilities, although they are there in the image, they are not actually loaded into the memory or not even used by the container during runtime. And this difference between saying whether a vulnerability belongs to a software package that is being used during runtime or not was something that we felt that we could answer this question really simply. And this led us to developing the reachability feature, where we are using eBPF monitoring of file activity in the containers in runtime in order to say which software packages are touched by the runtime. So the way we are doing it is, as you see here, we are creating an SBOM for the image that is running in a Kubernetes cluster. We are using SIFT and gripe for this. On the other hand, we get the observability stream of file operations from Inspector Gadget and looking at the SBOM and saying, okay, which package was touched during the runtime by the container and marking them as reachable or loaded. This enables us to create a short list of SBOM, an SBOM which only includes those software packages that are being used by the container during runtime, and remove all of those that are not. So, just some further explanation. Kubescape, we are big believers of open-ended integrations and APIs. The way it works that the Kubescape operator component detects an image that we haven't seen in the cluster before, triggers an SBOM scanning through our component, the kubevuln. Then the kubevuln scanned the image, created an SBOM based on what it saw in the image, and stores it as a Kubernetes custom resource. This custom resource can be accessed by all of you, and actually you will see that how it works. But in general, this SBOM is already the full SBOM. The node agent with the eBPF data stream is able to mark every entry on this SBOM as either something that we saw during runtime that is executed and loaded into the memory, or something that hasn't been. And therefore enables us to create a different object, which we call the filtered SBOM. So you have two Kubernetes API objects you can access with your kubectl, and you will be able to see the differences. So whether this is helpful, so I usually like this, although this is not an updated graph, I like to show it because, as you can see in the case of this Redis example, the number of vulnerabilities from around 150, 170 vulnerabilities, which are all the vulnerabilities that are existing in all the software packages inside the container, during the runtime, based on the runtime analysis, are reduced to around 15, and this is like something around nearly 90% noise reduction. So in general, I brought you like a few other examples. Postgres, Elasticsearch, you can see that only just 2/3 in these images are reachable of all the CVEs. In other examples, which are actually like quite good examples, are you can see also that only just a part of the vulnerabilities are actually part of software packages that are loaded into the memory. So over the time, we've been in contact, not especially with the Grafana team, but a few other teams, and us showing them, the results, enable them also to remove software packages that weren't in use and enable them to improve. And just last word, so in general, in the general population, we see at ARMO of how much you can gain from this kind of filtering is between around from 70 to 90% in the general application population. Most of the time, if you think about all those software, all those images that contain based on base images that are like taking Ubuntu base image or Red Hat base image, so very bloated base images, this gain of filtering is higher. In case of very slim container images, usually this gain is somewhat smaller. Back to you.
Cool. All right, so we have a great place to analyze supply chain data. We have some really great supply chain data. So it only makes sense to get all of that Kubescape SBOMs and filtered SBOMs into GUAC. So it's what I was just describing here with the collector. I just wrote and released a Kubescape collector for GUAC, just released last week. And a little bit about how that works is, as Ben mentioned, Kubescape is putting all the SBOMs into the API server as custom resources. So the collector is just a simple Kubernetes client that watches the API server for those SBOMs as they're there, and then automatically uploads them and ingests them into the GUAC system that you have running. Pretty straightforward. So I kind of want to show, like, now what can we do that we have all these different SBOMs in GUAC and try to analyze them and see what the differences are and explore that. So to do that, I'm going to show kind of a demo or a little bit of an example application. Before I show the example, I do want to show here. So this is the cluster that I have running. I have up at the top, I've got the regular SBOMs there, which are just the image scan or full image SBOMs. In the middle, those are the VEX documents, so those can go into GUAC as well, but I won't be exploring that right now. And then at the bottom is the filtered SBOM objects. And so to take a look at those, I'm going to use, I wrote a very quick sample application that, let's say you have a server and a job, right? So this is Go code. So both of these things live in one Git repository. They have one Go mod, but the server and job share code because it's one project, but they have different executables, different binaries that get compiled. So if we see here our packages on the right, I have a server and a job container, actually separate ones that get built. And for this example, in the Go mod, it has Gorilla and Zerolog, let's say, are two things that are used. But if we look at the packages, or sorry, the source code, the server is only using Gorilla; it's not using Zerolog. And then the job is using Zerolog, but not Gorilla. So remember that as we go and look at the SBOMs. So I had already run the GUAC collector that went and collected all the Kubescape SBOMs, but also I have SBOMs from a source code SBOM generator, and I also have an SBOM from a build time SBOM generator. And all of those have been put into GUAC. So normally, like I was saying, you would do an SBOM during your build, so we have that plus the Kubescape image SBOM and then the Kubescape filtered SBOM. So in GUAC, I'm here in the playground where I can write GraphQL queries and just run them and explore the data. And I have a query here that's just all SBOMs. And so I can look here and I can see that the file collector collected this result SPDX, and the file collector also collected this server CDX. But it's the Kubescape collector that collected all these other SBOMs here that we're going to look for. So the first one I'm going to look at, I have some more queries down here that take a look at all the packages in an SBOM. And this is just to explore. There's a lot more things that you can query in GUAC. And so I'm going to use the ID of the source SBOM there to query and see which packages are in there. And so this is I generated this with OSV Scalibur, and it has the transitive dependencies, but I see both Zerolog and Gorilla here. So this is an SBOM of your everything that's in your source repository. It's basically like looking at your lock file or that Go mod or that what is it, the Go shop file. Go sum. But that's not. Some of these things aren't being built into each binary, right? The job and the job and the server had different stuff. So this was source. So I already saved the IDs here from all the different SBOMs that I've ingested. This is the build SBOM ID, so I'm going to run that same query and look at the packages in there. And here we see what we expect. So it's my sample server and it just has HTTP Snoop, Gorilla, so Gorilla and the transitive dependency. So this, again, build SBOM is just going to be what actually goes into a build, what's going into a binary, something that's closer to what you're shipping. So when you're building SBOMs, those are some things to think about. And then now I'm going to take a look at the image SBOM. And query the packages in there. And the image SBOM has, oh wait, I'm seeing I have Wolfie stuff. I have base layout, and then of course all the Go packages as well. Not zero log, only the Gorilla Mux stuff that's built in. And then the Wolfie packages like CA certificates bundle and TZ data. So and then this was I didn't actually run an SBOM generator on the image myself. This was the one that Kubescape ran and put into the API server for me. Now, if I take a look at the filtered SBOM for, let's see, this was image. If I take a look at the filtered SBOM for this sample server, it's not going to be much different because this sample server is
using Go.
It's a Go binary. So there's only one thing in the whole SBOM. So the filtered one is pretty much the same. But I did import a filtered SBOM on a Debian-based image from Kubescape. And let's run the query on that one. And so we see that, yeah, there's Debian packages here, libsSL, libsc Linux, etc. But if you look through this whole thing, it's not very long. So there's only the stuff that's actually running is coming in the filtered SBOM. And then before getting back to the slides, I just wanted to take a quick peek at the visualizer. This is the visualization of the graph. It's kind of hard to look at all the little dots and things in the visualizer. So it's neat to show and say, like, hey, this is the image, and then this is all of the SBOMs together. So this isn't filtered. This isn't just looking at one SBOM. So this is the image and all the dependencies between, say, like Go packages, and these are the Wolfie packages, and then the occurrences of the artifacts, and et cetera, et cetera. All right, so I'm going to jump back to the slides, and by exploring all of those SBOMs, there's some takeaways here. There's some things that we've learned. So again, source and repository SBOMs are basically parsing the lock file. They're getting you everything in the repository. So that might be also stuff that's important to you, like dev and test dependencies, but maybe they're not as high priority to you, right? So things to think about with stuff in there. Your build SBOM limits to only the stuff that's being built into that executable. Something that you have that's being either during the build of your software, whether it's being compiled or if it's interpreted language, maybe there's some kind of dependency resolution that happens during the build that is not reflected in the source. So, but also, if you have a build that's like maybe part of your CI for testing, that may not be the exact same build that's what you're shipping to production. So that's something to keep in mind when you take a look at build SBOMs. And then image SBOMs, scanning the container. Again, you're not getting your dev and test type of libraries or stuff that's being built, that's in the repo, that's not being built into the image. And then you're also getting all of the operating systems level stuff. And then this is much closer to what you're running in production, but again, it's everything. And then the filtered SBOM, has been covered, is only the binaries that are getting loaded into memory. So the very, very most important thing to take a look at. And so I don't want to say pros and cons, but there's just different things in different SBOMs, and there are things that you have to know, and when using something like GUAC can help you kind of explore the SBOMs and see which packages have the right relationships to which SBOMs are the ones that you're looking for. So main takeaways there. And that brings us to the end.
Yeah. First of all, thank you for attending. I know this is the last presentation for you at this KubeCon, and I was really impressed by the turnout. So thank you very much for everyone, and we'll really hope to see you also in the next KubeCons, and maybe also either joining either of these projects as contributors or just like giving us feedback. We'll be happy to be in touch, and we'll be happy to take questions.
Yeah, there's a mic in the middle if you want to speak in the mic to ask questions. I also have GUAC stickers for afterwards, if you want one. Go ahead.
Hi, thank you for the talk. I have a question. Does it matter when you query the filtered SBOM? So is there a chance that the filter is missing some vulnerability?
So I can talk on the Kubescape part. So in the Kubescape, by default, we have default setting of for how long we are monitoring a container. So when you start a container, it takes us like 2-3 minutes to create the first filtered SBOM. And we are like every 10 minutes afterwards, if we see something new, we are updating. But after, by default setting, I think is around 3 hours or 6 hours, we are just stopping monitoring in order to reduce the CPU load, although this is not a big load. But having said that, if mostly from most of our experience after things we didn't see in the first few hours, they are usually not really relevant. But again, this is something that you can customize.
Thank you.
Hi, I just have a question on the runtime package detection. Is that 100% accurate, or does it depend? Like, is it always definitely accurate that these are the only ones that are loaded during runtime, or is there some inaccuracy to that?
So, okay. So let me, I'm putting my engineering hat on it. So there are like 2 inputs here, right? So one is the SBOM, the second is the eBPF data. So in the SBOM, we are just as accurate as the SBOM generator is. So we are using SIFT. SIFT is rather, I really like the project. It's a great project, and it's one of the top-notch SBOM generators from images. So we might have like things that we don't discover during the creation of the SBOM from the image. And the other inaccuracy could come in theory from the eBPF data stream. So in the eBPF data stream, we'll see that which files are touched during the runtime. So either there is an OpenSys call or an exec.sys call on them. In this case, there is a way that maybe the CPU is overloaded, and then we are missing some eBPF events. And missing eBPF events could lead to inaccuracy, and we are not marking some packages as loaded while they should be. Now, in that case, if I remember correctly, we stop generating, if we are missing eBPF events, we are stopping the filtering process because of inaccuracy, and we don't want to create inaccurate objects, but this barely happens. Like, it has to be like some really crazy thing going on in order to not be able to process all the data and just like running out of the CPU limits we have and missing information. But there is like this distant, possibility, and you would get a log information, and you would be missing the filtered SBOM in that case.
Thank you.
All right, thank you very much.
Thank you very much, everyone. Have a great weekend.
Yeah.